today I'm going to introduce the plugin version of BassBalls pedal, and this presentation is part of MMI603 Audio Signal Processing 2 class music engineering program at University of Miami. This plugin is based on Electro-Harmonics BassBalls Nano Twin Dynamic Envelope Filter pedal. This pedal was released in the early 70s and has been reached around 2005. The pedal contains two resonant low-pass filters in parallel, and the cutoff frequency is modulated by an envelope detector. The audio detector tracks the input signal and triggers the filter modulation based on the attack and release time when the input signal reaches the threshold or response in the pedal. In the original, the filter's cutoff frequency keeps a constant ratio as the higher filter's cutoff frequency equals n times the lower filter's cutoff frequency. Both filters' Qs are identical and cannot be modified, but also Qs vary as the cutoff frequency changes. It is a side effect of the circuit that the manufacturer had chosen. However, it makes the modulation sounds more musical. Even the name of the pedal is BassBalls, but it's also widely used with other instruments such as guitars and synthesizers. The BassBalls originally has three controls: bypass, distortion, and response, and the user doesn't have controls for cutoff frequency or Q for the two low-pass filters. In the plugin, new features as controls of cutoff frequency, Q, attack and release time, and many other more add to give the user more control of the sound. These features will be explained in detail shortly. The products follow the block diagram here. Based on the input signal and the controllable attack release time, the envelope detector sends envelope data to the cutoff frequency calculator. With user-controlled threshold, sensitivity, minimum cutoff frequency, and Q, the ASPiK calculator modulates the cutoff frequency and sends it to the two resonant low-pass filters. Users also have access to built-in distortions. In the plugin GUI, user has control of distortion, center frequency, Q, attack time, release time, threshold, and sensitivity, and the bass control, limiter, and analog modeling option. One unique feature in this plugin is the Moog Ladder filters. Robert Moog's Ladder filter is a fourth-order low-pass filter designed specifically as an analog voltage control filter circuit. As the Q is raised above 0.707, the filter's overall gain drops, producing a massive reduction in bass frequencies. The resonant frequency of the filter changes as the Q increases as well. If you need further information about this filter and the reproduction of the digital version of it, you can go down and check the link attached in the video. The Moog filter is well known for its distinctive sound, but also takes out the bass frequencies as the Q is increased. And as BassBalls is a pedal for bass, there are additional controls that bring this low frequency back, the bass knob. There is one more interesting character in the Moog filter. When we set the Q above 9.8, it will start self-oscillating. And this is the reason the maximum value in our plugin is 9.8. as the Q is set as 9.8, you can hear the slight oscillation, but it won't fully be turned as a sine wave. In the original Moog synthesizer, the nonlinearity of the hardware works as a sub-limiter and tame the output down. In this plugin, it is replaced as an optional hard limiter here. On the top of the original distortion selector, the option for distortion is also added. The user can choose non-distortion, sub-distortion, and hard distortion based on their needs. In the original BassBalls, the cutoff frequency and cues vary due to the analog circuitry. This non-linearity makes the pedal sound more musical and distinctive, and the analog modeling mode here can recreate this sound. In the analog modeling mode, the cue control will be bypassed and it will be buried as input signal. And there are 5 presets, which you can see here, and I will play one by one. And this is it for today. I hope you enjoyed. If you have any questions, please reach out to me. Thank you.